So the question here is, find the general solution to this system of ODEs. What makes this difficult is that there's a lot of different variables. For example, in equation 2, you have y2 and you have y1. So hopefully, depending on whatever system they give you, there's already an equation which only has one variable, because you can easily solve this. So even though it's overkill, you could solve this one using the characteristic equation. You have that r is equal to 3. Therefore, your solution, your general solution to this individual ODE is going to be a constant times e to the 3t. So now we can then focus in on the next equation. So the next equation has two variables. We have y2 and y1, but we know what y1 is. So then equation 2 then becomes y2 prime is equal to, we can substitute this, the general solution for y1, so it's a times e to the 3t plus y2. So in solving some of these, I've noticed that it's confusing the students that we have y2s and y1s in here. So if it helps you, you can ignore them, erase them in your mind, and look at this at fresh. How do I solve this ODE? Well, I can use the integrating factor. So put it in a form that is useful, one which you are used to seeing. Then the integrating factor is going to be e to the antiderivative of whatever is in front of there. So what is that? That's -1. The antiderivative of -1 is just -t. So we then want to multiply both sides by this. So multiply by r of t, multiply by r of t. The left is going to become r of t times y2 in parentheses, and you take its derivative. The right is just a times e to the 2t. We are then able to integrate both sides to get r of t times y2 is equal to, well, the antiderivative of this is e to the 2t, and we also want to divide by 2 times a, plus a constant. So then multiplying the reciprocal of r of t, we're going to get the y2 is equal to a over 2 times e to the 3t plus b e to the t. So that is our general solution for y2. Calculating y3. Let's see what y3 is. So y3 needs to satisfy this third equation. Notice the similarity between the second equation and the third equation. What's the difference? Well, the difference is instead of 2's, you now have 3's. So if y2 satisfies equation 2 and y3 satisfies equation 3, I want you to notice that both of them are a solution to y is equal to y1 plus y, and then there is a derivative on the far left. So both of these satisfy the same ODE. So they're the same general solution with a different constant. So using this fact and remembering that A was given, it wasn't part of the solution, we know that y3 is equal to a over 2 times e to the 3t plus a different constant times e to the t. So then what should our answer look like? I get students asking, well, do I add these together? No. Remember what the original question is. Solve the system, meaning what is y1, what is y2, and what is y3. My answer should involve 3 different functions. So I'm going to go ahead and copy my first answer to what is y1. I'll paste it there. I'll go ahead and copy the 2 new answers and put them here. This here is the answer. These 3 functions is the general solution to the system of ODEs.